Let's get a good picture of a graph of the function y equals cosine x. And this will be one that you add to your lexicon of functions that you know and recognize and can reproduce at will. We'll start with a framework. So I'm going to start with those quadrant angles. 0, pi over 2, pi, 3 pi over 2. And then when we get to 2 pi, we start over again. The cosine is periodic. Starts over, repeats. So let's see. Cosine of 0 is 1. You can use your unit circle for this. Use those quadrant angle points. Cosine of pi over 2 is 0. Cosine of pi, we're at -1. Cosine of 3 pi over 2 is 0. You might be having deja vu a little bit to the sine function. Those look familiar. So here we go. I'm going to put in my important value, my quadrant angles here, hopefully about the same distance apart. So we're nice and evenly spaced. There we go. Okay, so I have a point at 0, 1. I have a point at pi over 2, 0. Pi -1. 3 pi over 2, 0. And then 2 pi, we're back to where we started up here at 1. So there's kind of my beginning framework. And similar to what we did with the sine function, we want to fill in values in between so we can see what it looks like. That's not quite enough to get a picture yet. So I'm going to look at quadrant 1. I'm going to use my unit circle. Looking at cosine, the cosine function, so those are the first coordinates of each of these points. Root 3 over 2, root 2 over 2, 1/2. Well, okay. Those are exactly the same as the sine function was in quadrant 2. Well, root 3 over 2, root 2 over 2, 1/2. Well, that tells me, without wanting to do too much additional work here, that the cosine function in quadrant 1 is going to look exactly the same as the sine function did in quadrant 2. Fortunately, I have my handy dandy sine function right here. Sine function in quadrant 2 went from pi over 2 to pi through those values. Cosine is going to look like that in quadrant 1. So same shape, just moved back. In quadrant 2, starting at pi over 2, here's my unit circle again. In quadrant 2, my cosine has values -1/2, -root 2 over 2, -root 3 over 2. Those are the same as the sine values, the second coordinate, had in quadrant 3. -1/2, -root 2 over 2, -root 3 over 2. Same values, same order, so I'm going to have the same shape. The cosine function in quadrant 2, that's here, is going to look the same as the sine function did in quadrant 3. And you may have guessed already, this is going to keep going. The cosine graph is going to look exactly the same, and I do mean exactly the same as the sine graph. It's just a quadrant ahead. So shape is exactly the same as it was for the sine graph. In fact, we lump these together, sines and cosines, under the collective name of sinusoids. And we can sort of use sines and cosines interchangeably. In fact, I could write cosine x as a sine function. Let's see, this is the sine function pulled one quadrant to the left. One quadrant has a length of pi over 2. If I move it to the left, I accomplish that by adding inside with the x the amount that I'm shifting by. So I could write cosine x as sine of x plus pi over 2. The sine function shifted pi over 2 to the left. Both of these, since we lump them together as sinusoids, they're both functions, sines and cosines. So we can talk about function-y type things like domains and ranges. The domain of a sinusoid Well, I can put any x value in here that I want to a sine or a cosine and get out a corresponding y value. So the domain is all real numbers. If you like negative infinity to infinity, that works. Symbol for all real numbers if you haven't run into that before. And we can also talk about a range for a sinusoid, just the generic ones here. Range is y values. Sinusoids have a definite top and bottom. The highest it ever goes is 1. It's the top. There is no graph of the sinusoid up above there. And the lowest it ever gets is -1. So my range, y goes from -1 to 1.